Welcome to Excel in Simple Terms, Part 2, Designing a Game. Today we're looking at building helper functions for your game, and this is a continuation of Part 1, where we've basically created our initialization file, worksheet, our map main, map terrain, and the map lookup. So we are going to need to build a couple of helper functions. This is just going to streamline things in our sheet, so it's a little bit less coding, and also to just organize it a little bit better so it's easy to find specific functions and tweak those functions as we progress. We also, on our toolbox that we created, we're going to add every new sub or function that we create, we're going to add on there if it is a main function. For instance, the map generation we're going to add onto the toolbox so that we can see, so we can generate a map as we program, and we can see what the effects is of the changes that we are making. So to start off with, we're going to jump straight into Excel. One of the things that we're going to do is we're going to build a function that's going to help us a little bit with things like these tables and the grids being your map terrain grid and any other grid that eventually we're going to be building. The map is totally going to be driven by these grids. So we're going to have a grid that's like we have now with the terrain, and then we may have another grid that with an equal amount of cells that is going to keep track of things like your rain on that specific grid, and the population on that grid, and all those components of what makes up that grid, the value of the grid for when you buy and sell the land. That is, each one of them is basically going to be another grid, just like this map terrain grid, which at the moment is 100 by 100, but I'm going to change it to 101 by 101, and the reason for that is on 100 by 100 you don't really have a center of the map, because you actually have 4 squares that's the center of the map. With 101 by 101 you actually have a cell in the middle, which is basically row 55 by column 55, and that is the center of the map. It helps with when we generate in the next section of or in part 3, we're going to be generating a little bit of a better map that's not square, and to have a center of the map makes it possible for us to actually start at the center and work our way outwards to get certain components of the map a little bit more just in a nicer shape. And for that reason I'm going to change the grid to be 101 by 101 instead of 100 by 100, and you'll see that there is definite benefits when you try and auto-generate a map that's random and different every single time. So to start with, we are going to have a look at a couple of our functions that we're going to do. So the first function that we're going to build is, on these grids we don't want to have to put in worksheet and the sheet name and the cells and the row and the column every time. We want to try and get rid of all the keywords. We just want to call a function, so something like read grid and write grid, and we're going to pass 3 variables to it. It's going to be the actual sheet that it is, the grid that it's referring to, so like map terrain, the row and the column, and that's it. We don't want to have to reference cell, and we don't want to have to reference worksheet. So all we're going to do is basically create that in a function or in a subroutine, depending on whether we want something returned or not. So obviously functions expect some kind of return. So you're going to pass, let's say you have a function that is adding 2 numbers, so you're going to pass to the function 5 and 5, and it's going to return 10. But a subroutine isn't going to return anything. So for a write function, you want a subroutine because you don't need anything to be returned. Once it's written, it's your result is the change on the actual grid. Whereas for when you read, you actually do want the value back that you are reading. So you'll see that I always create individual modules for the different components of what I generate. It makes it a lot easier as your everything starts growing and your game starts getting more complicated. It makes it very much easier to find things. You want to quickly make a change to a function, you can just see based on the name that we've created here where that function sits. So we're going to start with inserting a new module, and I'm going to call this module, so this is now for the grid. So we want this is related to any grid, so I'm going to call it general, and this is normally general is the first part that I use for anything that's going to be used in quite a lot of different places, and that's not so my keyword in the beginning is either general or it is related to the specific thing that is happening in the game. So I'm going to call this general, and I'm going to call it read grid. And then I'm going to have another module that I'm going to insert, and that is going to be general, and it's going to be write grid. And the way that I do it, you can see that everything that is general is then obviously this is sorted in alphabetical order, so it's together. So when I want to make a change to how the grid is handled, my read grid and write grid is right there next to each other, and it's easy to get to and do my changes. So it's going to be a public function to read, and I'm going to call it read grid. And what I want is my table, and I normally call it database DB. Technically it's probably not a database, but I mean Excel is really a storage area for data, so I call it a database, a row and column, and that's the variables that I'm going to be passing to it. And what I wanted to do with those variables is so read grid equals, and I wanted to reference the database that I'm pushing to it, plus the cells where I want to return the row and the column. I'm not going to use column like that, I'm going to just make it col, make it a little bit shorter, dot value. So this is going to return, if I pass to it that I want map terrain in the database variable, and row 1, 1, it's going to return water, which is in row 1, 1 on that table or on that grid. So that makes it a little bit easier. Then I'm going to, for the write function, I'm going to create a subroutine, and I'm going to call it write grid, and it's going to be again database row and column, and in this case I want again to refer to the worksheet, so I'm just going to copy that, and it's going to be the other variable that I need is my value, because I want to obviously write a value into it, so I need to pass the value to this, and I'm sorry, dot so that is my function to read and write my grid. So to test it, I'm just going to create a temporary sub test, and so in order to read my grid, I'm going to have just temporarily, I'm going to use x equals read grid. I'm going to refer to my map terrain, and I'm going to refer to my row and my column, 1, 1. Okay, so I'm just going to do a message box. Oh, let's do a debug print, and that's going to be X. So I'm going to run it. So I'm stepping through it now. You can step through it by pressing F8 if you're not aware of that. So you can see X value is empty at the moment. Now it's jumping to my function and it's going to read what's on the grid. And you can see read grid is water, which is in 1, 1. And my debug print therefore is water. So that is working. Now if I want to write the grid, let's say I want to change the cell 3, 3, which is C3. I want to change that. At the moment it's soil, and I want it to be water. So this is basically the command structure that I'm going to be using throughout my code to just reference it quickly and to just streamline how we write our code. Okay, so with writing my grid, I don't need to put in the brackets because it's a subroutine. Okay, write grid, it's going to jump to write grid function. It's going to basically then call the built-in functions, worksheet, cells, and there is no X, so it's obviously going to ignore the debug print, but you're going to see on 3, 3 it now has water in that cell, and that's what I wanted to achieve. So it allows me now to use this kind of format in future to write to specific cells on my grid. It just saves me from having to type this worksheet in cells every time. I'm going to just have I basically have my own standard method of writing to my grid, quick and easy. Okay, so then we have to have a dice. I mean, all games have a dice, so I'm going to take this one, I'm going to copy it into my read grid section, so that's going to be my read grid, and this one is going to be my write grid, and voila. Now I'm going to build a general dice. Insert module, so this is going to be a public function because I wanted to return, oh goodness, what happened there? It jumped. Public function dice, and I want to give it a minimum dice and a max dice. So I want it, when I call dice, I want it to return a value between those two numbers. So to do that, first I have to randomize the timer. Then I'm going to use dice equals min dice plus int rnd times max dice minus min dice plus 1. Okay, and this is the method that you use. There's another way you can do it, and that is by using a worksheet function. So essentially what it's doing is it's calling the built-in function that's in your worksheet when you normally put in when you call randomize in from an Excel spreadsheet. The reason why I prefer this function is I've tested it on files where there is thousands of entries, and it tends to take longer to call the worksheet function. So this for me works a lot faster. If you prefer the worksheet function, it is available and you can call it from here, but this is the method that I'm going to be using for my dice. So to test this, subtest, and we're going to say So the result equals dice, and we're going to give a so we want a dice between 1 and 6, and we're going to just print out debug print result. So let's step through it. You can see it's running through, and debug print, it's giving me 6. When I run it again, you're going to see I'm getting a different result, and it's going to keep on doing that somewhere between those values. So this is what we wanted. We now have a dice function. Now the next function we're going to write is it's a function to read our tables, read and write our tables, similar to what we've done now with the grid, but it is for something like these kind of tables, the init, and later on we're going to create one like this for the player that stores all the players' variables. Now the reason why I like to write a function for this is later on in the game, as you build the game, you're going to realize that things do not sit quite together where you want them. Maybe you want everything to do with a button that's clicked together, and in the meantime you built other functions and you've added those variables below it. So now you're moving it up, but your code doesn't know that. So within Excel, everything knows if you cut and paste to a different spot, it knows that you've done that. But your code is separate and it doesn't know that you've moved the variable. So for instance, let's say I move this to row 24. Now it's going to come, I'm going to run my code and it's going to go to row 3, it's going to not find it, or you've put some other value in there and it's going to find that instead and use the variable that you've put against that. So to avoid that, I like to be able to move the stuff around. The only criteria is that obviously you can't change the name. If you change the name, you will have to go and change the code. But as long as you've kept the same name, I wanted to be able to look at these, all the names here, and look at my headers and find the actual correct result. So I can move it wherever I want to. The only thing that you cannot do is you cannot have 2 of the rows with the same name. So I cannot go and create another row. I'll have to call it row 5 or give it another name. Otherwise, when this function runs, it will pick up the first one, whichever that is, and it will ignore the second one that's got the same name. So to do that, firstly I have to give these things headers. So I'm going to call this this one description, and this I'm going to call value. So in my code now, I'm going to go and create I'm going to insert another function. There's my module inserted, and I'm going to call this general, and I'm going to call it read table. I want to make it a public function, read table. Okay, so what I'm going to pass to read table is I need the database, I need the row name, and I need the column name. Because those are the things I'm going to pass to it. I'm literally going to tell it, go and look on init, find the word row in the different rows, and find the word value in the columns, and return whatever is associated with that row. So row can be here or it can be here, it doesn't matter, it's always going to find the value that's next to row. So to do that, I need a couple of functions. So firstly let me just create the framework for what I want to do. So I'm going to do a public sub for write table. I'm also going to use database, row name, column name, and a value, because remember I need to pass a value to it to be able to write into this table if I want to change the value that's here. But In order for this to work, I need two additional functions. First, I need a function that's going to go and find the column that houses it needs to go and look through the columns and find me value, and then it needs to look through the individual rows and find me row to be able to return that value. So I'm going to basically build two helper functions. And these helper functions are going to ask for, so the one I'm going to call getColumn. It wants the database and it wants the column name. It doesn't care about the row name because it's not going to look for a row. It's only going to be looking for a column. And I'm going to say worksheet function dot match column name comma worksheets, sorry, and it's going to look for the DB. So it's basically in the same format as what you would use the match function in Excel. So it's just the actual wording that's slightly different, because obviously you cannot call the function directly like that in VBA. So DB, and I want to give it a range. So I'm going to assume that on my tables, my headers are always going to be in range 1-1. If you decide that you are going to build one where it doesn't always sit in range 1-1, sorry, I need to put quotes there. If you decide you're going to build something where it's not always in range 1-1, then you're going to have to pass another variable to it that tells it in which row it can find it for a specific sheet. Now I try to avoid that with the game. I don't want to have to build something different or a new function for every single one of my tables. So I build my table so it always has a header in the first row, and then the next one I'm going to build is the public function to get my row, and it's also going to get to the database, and it's going to get the row name. Sorry, public, I can't spell today. And it wants to get the row, and it's interested in worksheet function dot match. It is looking for the row name, and it's going to look in the range of worksheet database dot range. And the same thing, I'm going to always look in range AA. Again, I don't want to have to build a separate function for each different table, so I just keep it consistent. Now that we have those, we can actually go and call those functions. So what I'm going to do here is I'm going to say column equals getColumn. I'm going to pass my database. Sorry, I don't need that, I just need database. I'm going to pass the column name, and then I'm going to do the same for row. Get row. Oops. DB and row name. So now I have my row and my column, and I can do a read table. I can say read table equals to worksheets database dot cells of my row and my column. Voila. So there is that function, and now I'm going to do one for the right table. Again, I'm going to get my column. Database. So public sub, right, WX, okay, so worksheet database, sorry, database, I can actually just copy that. Let me just copy that. Okay, so it's returning my row, my column. And then I'm going to set my worksheet database dot cells row comma column equals to my value. So let's test it. I'm going to open this file so it just sits on the side and you can see what it's doing. So let's do a test. Public sub test. We're going to first do a read table in it. Comma, my row name is going to be row, and that needs to be in quotes. It's a name, string, and my column is going to be value. And we want to set that equals to whatever our, so I'm going to say test value equals, because it's reading a value, so it needs to put it somewhere. It's reading it, that function is going to run and return the read table into test value. So let's quickly see if that's going to run. It's getting the column. It's bombing out of my row. Let's see why it is doing that. Database. On my worksheets. Today I seem to have a problem with typing worksheets. Okay, so it's stepping through that, and read table, it's setting it to equal, and test value is 40. So that is the value that's in there, so the read is working. So let's do a write table. Okay, so here we don't need the brackets because we're writing to it and it's a subroutine. And we are going to pass, we don't need quotes because it's a number that it's an integer that we are passing. So let's change it to 50 and we're going to run this. Okay, let's run it. Again, worksheets. Stepping through it. Finding the column, finding the row, setting it, and it has changed my row to 50. So you'll see after every function or subroutine like this, I normally just do a little test so I can make sure that things are running the way it is expected to run. Because a small thing like the S behind worksheets can cause havoc later on when you run it and you haven't tested the components, then you need to step through it, maybe a lot of code to get to where the problem is sitting. Okay, so that's my write and my read table. So we've got the helper functions that is supporting these two functions, and we can now read and write to a table. We can just test column quickly if I use any other name, as long as the name is there. You can build an additional component on error if the name is not found, that it doesn't pop up with an error. that it actually did, but you know, I don't like that because I don't want to accidentally pass over a value. So I want to know if there's an error in my code. So I do not normally build the on error function into something like this, where you know, I rather test it, make sure that it is pushing a value, and if it cannot push a value, it means I've messed with something that I shouldn't have messed with, and I need to fix it. So I'm going to just pass to the column, we're going to pass 50 as well. So let's see if it runs. So I'm stepping through it, and you can see the column has changed to 50. So this is working. Okay, so I just want to neaten it up a bit. Now I'm going to remove my tests. Let's want to make sure I've removed my tests in my other sections. Okay, so that's removed. My right grid test is also removed. Okay, so now I'm just going to clean it up a bit by taking my functions that I've written now for the right table, and I'm going to create it as two components. I'm going to put the I'm going to call this general dice. That's right, so I'm going to just insert a module. So I'm going to call the general helper, and this is for tables, or I'll call it table helper. Okay, and I'm going to take my two helper functions, I'm going to just put them together into the general helper, the table helper, and then I have my read function here, but I want my write function in its own module. General, wrong place where I'm typing, general, write table, and I'm going to take the write table out of here and put it in its own module. And that's it. That is some for that helper function. Now there's one more helper function that that we are going to need. So the helper function that I want to build is a little bit more tricky. It is when you run a map, you want to be able to, you know, we want to enhance this map. So to be able to do that, you're going to have to look at all the cells around the cell that you want to manipulate. And what you want to do is say above it is water, and below it is water, and next to it on the left is water, and next to it on the right is water. So in that case, it's very likely that it must be water, unless you have another set of rules. So in order to set those rules, what I normally do is I create a function that I call choose one of 10. The reason why I gave it that name is because into this function I'm going to pass a variety of values. Now they're all optional variables. The first variable is going to be default chance, and that is just going to tell me that if you cannot find a solution, then use that as my default. The other 10 variables that follow on it allows me to compare 10 items and say grass in this block has a 10% chance of being there, soil has a 20% chance of being there, and I don't have to use all 10 variables, but it allows me up to a maximum of 10 variables that I can compare. So I'm going to just show you roughly on another sheet how this thing works. Okay, so it starts off with, you've got a dice that's going to be thrown, and it's going to generate a value up to 100. So you have in this section you have 10 possible things that you can compare. like grass and soil and whatever. And this thing can be used in a lot of places in the game, and not just in the game. It can be used in a lot of other places too, with business logic. And when you do, I've used this kind of sheet with chances to do scenarios for banks, where they give you percentages. You know, a statistician would give you percentages of a chance that something can happen. You load it into this, and it will kick out a random value, like a 53 or 26 or whatever, and compare it to your chance for a specific thing to happen. So the way it works is, firstly, I tell it what my default is. So remember, you've got 10 possible things that you can compare. So you're going to tell it if it if the value of the 10 things together is more than 100. In other words, like here, I put 11 in as the chance of 11% is the chance of this happening, and 10% is the chance of everything else happening. But you can see it adds up to 101, which is impossible. It can only add up to 100% chance of something happening. So if I change that to 10, obviously then it works perfectly. So what it then does is it throws a dice, and let's say it is 92, and you have a 10% chance of all of these things happening. So it's going to then look at the 92 and say, well, it is going to be 10 that's happening, because 92 falls in the range of 91 to 100. So if I change it to, let's say I remove all of these, and I only want to compare 3 items, a 30%, a 30%, and a 30%. So it is 90% chance that it's going to happen. Now, that doesn't make sense. It needs to add up to 100%, but you can feed it 90%. What it's then going to do is, if I said the default is 1, it's going to take whatever the difference is and add it into 1, because the chance of 1 happening, the default happening, is the highest. So it's going to then add that into your first option. If I say 2 as my default, it's going to add it into the second option, whatever the difference is. So in a case where I say there's a 33%, now remember, these are integers, so they cannot have fractions in it. You can build one that has fractions in it, but for game's purpose, we want to work with round numbers for most of these things. And so for that reason, I stuck to integers. Obviously, you can use the exact same method. You just need to specify that it is not an integer in your code. So if I say there's a 33 and a 33% chance, and there's a 50% chance of this. So now, because it is not lower, it's not going to add it just into the default. What it is going to do is it is going to step through them, and it's going to say you have 3 options, and the chance of this happening, this 50 happening, is it's going to basically deduct 1 off each of them to try and balance it out. So it's going to try and equalize it back to 100. So it's going to take the 1 off each of them until it reaches 100 in this position. And then it is going to take that, whatever the difference is, in other words, in this case 16, and it's going to try and it's going to try and split it between these 3 items. So it's literally going to reduce. In this case, in order to get to 16, it needs to get 16 down from it. So it's going to take 16 divided by 3, because there's 3 options. So it's going to take 6 off each of them. And it's going to get these values. And these values, these 3 values at the moment is 104. So it knows that it needs to take, we need to remove that. So it's 104 still. So it needs to take 7 off each of them. Now it's getting to 102. So no, it knows it needs to take 8 off each of them, and voila, it is 100. Now in the case where this was, for instance, 51. So if it took 9 off them, it's going to be 1 less. So what it then does is it takes that extra 1 and it's going to add it to your default. So it is really just a way of passing the values to it and getting it to kick back out just one option that is true, and all the others are not true. So, so you're going to pass in soil and grass and water, and you're going to say give it each of them a percentage. It's going to make sure that the percentage cannot exceed 100%, and then it's going to throw the dice and decide in which range it falls to be able to pick one of those. And that is basically how the function works. So now I'm going to show you how to code it. So first we are going to get our, so I just want to get to it on my other sheet. Okay, so first thing that we're going to do is we're going to define it, and because we don't want, if you pass no variables, if you pass no default chance, you pass no chance of any of those things happening, of the different possibilities, it's going to assume that that the default chance is 1, and it's going to assume that everything else is 0. So it's going to kick out none of them as an option. It's going to return 0 as a value. So what we want to do is first we want to publicly define the public function. So I'm going to insert a module. I'm going to call this guy general, and we're going to call it choose 1 of 10. You don't have to use 10. You can reduce this. I just use 10 because sometimes in a game you get a lot of options that you want to compare. I've never had to exceed 10 things that I'm comparing in one go. So for that reason I use 10, and this is what you are going to put in. You're going to put in public function, choose 1 of 10, and every single one of the variables will be an integer, because you're only going to throw dice up to 100, so you only need to return integers. And I'm going to do a default, a chance A, B, C, D, E, F, etc. up to J. That's 10 variables plus a default. Then I'm going to say, I'm going to create a if missing, because remember, because you're creating it as optional variables, there's a chance that there's going to be no variables, so you need to tell it what it's going to need to do with that. So this is what I'm passing. If is missing default chance, then default chance is 1. So it's then going to default to 1 if there is no default. Then what I do is I go and add all of these default chances. I'm adding together because I want to make sure that they are 100. So first I'm adding them together, and then I'm saying if the total chance equals 0, then the chance for A, so if you put nothing in, it's going to be A. Whatever A is, it's going to return 1. Then I wanted to decide what it's going to do if the total chance is greater than 100. So what I'm doing with that is I step through it with a do while loop, and I reduce each one of them with 1. You can see if total chance is greater than 1, then do while total chance is greater than 1. It's going to step through each one of them, deduct 1 off it, and then add them together again and see that it does not exceed the number. So it might step through it quite a few times to get to 100, but as long as it is less than 100, you don't want the total chance to be greater than 100. It must be, if it's less than 100, then I'm going to do the next step, which is basically adding the difference into the default. And what I do there is an if statement. So the if statement looks like this. I just want to do the formatting right here, and this one here also, my formatting is out. So if the chance is less than 100, then I create a new variable called chance k. So chance k equals 100 minus the total chance. So that's going to give me the difference between 100 and say 107 that it's passed me. And I then go and I add 1 to each one of the variables until I get to a point where I cannot add to the variables anymore, and then whatever the difference is goes onto my chance A. Because my default, that's if you have not specified a default. So if the default is 1, that's what it's going to do. It's going to add onto chance A. If the default is 2, then it's going to add onto chance B, etc. If the default is less than 1, in other words, you've not specified 1, it's 0 or it's minus or something weird, then it's going to add it. It's going to add it onto my chance A. So now the other option is also if it's greater than 10, because we can only run up to 10. We're only comparing 10 variables. So if it's greater than 10, it's also going to assume that it's going to be chance A if you have not specified a default. Now I need to throw the dice, and this is basically the dice portion. So I throw a dice. Remember we created the other function called dice, so my dice is from 0 to 100, and choose one of 10 is going to be automatically 10. In other words, I'm saying it's automatically J, but now you're going to do a comparison to see if it is not J, if it is something else. So the way I do that is with this section. If chance dice is less than or equals to all of the chances of everything together, then choose 9, because then it can't, if it is less, if it is more than 10, then the choice that it must make is 10, because it obviously fell within the range of, if you for instance pick 10% for each one of them, then it's going to be in the range of 90 to 100, and that's going to be 10. But if it is not, all of the variables together, so up to J, you can see this up to I, then it must choose 9, and so it reduces, and it keeps on changing the choose of 10. So the choose of 10 will become 6, 5, 4, 3, 2, 1. So it's kind of stepping down. If it cannot match the values, it doesn't fall in that range. So essentially what it's doing is comparing each one of them to see if the dice and the chance of that happening falls in the same range. Then finally, at this point the function ends, because we have now decided which one it's going to choose. It's given us the choose 1 out of 10 value, and we can now use this in our program to determine a chance. And let's test it. Chance test. So we're going to say x equals chance, sorry, just want to get the name, it's choose 1 of 10, choose 1 of 10, and the default that we're going to give it is, let's say we're going to give it 1, and the chance A, so let's say we're comparing a grass and swirl, so we're only going to have 2 options, and there's going to be a 50-50% chance. And remember, although we're dealing with percentages, you're going to put it in as variables, because that's how this is written, to take it as a variable, so you're not going to put the percent sign in it, and then we want to see what it's going to return. So you can see the first thing it does is it jumps into our function. You're going to find the default chance is there, chance A is there, chance B is there, but everything else has a 0 variable. So it's going to just step through them. It's happy with the variables that it got. It's going to add them all together, which gives us 100%. If total chance equals 0, so it's not 0, because we want to force it to be 0. So if you haven't given any chance options, then it must be 0. And then we're going to say if total chance is greater than 100, and it is not. If total chance is less than 100, it is not. It is exactly 100. So now it's going to throw the dice, and it steps through that function, and it gives you 62. So logically, because we have 62% chance, you split it exactly in half. So the first 50 of the 1 to 100 dice belongs to chance A, and the other 50 belongs to chance B. Because it's 62, it falls in chance B's range, so it must choose chance B. So you can see it's setting it to 10. Most of these variables are none set. It won't set it to it set it to 10, and now it reduces it to 9, because it is still your chance is still smaller than all of these things together. Your chance is still smaller than all of these things together up to H. So it's setting it down to 8. Now it's checking again and setting it to 7. Checking again and setting it to 6. But remember, there's no variable, so it can't fall in those ranges. So it will keep on setting it down. It can only be 1 or 2. So at this point, it's setting it to 2, and it cannot set it to 1. You've seen it jump out of that. It cannot set it to 1 because it belongs to 2. And X is therefore what it returns is 2. So it is option 2 of that dice that you threw. And that is, for now, the all the additional functions that we're going to write and that we're going to be using throughout our game. I think if I look at the time that this video has been running, it's getting to kind of the limit that, so I'm going to do another section where we're going to handle the other things that we wanted to tackle. I'm going to end this video at this point, and look forward to seeing you in section 3, where we will tackle just those couple of issues with things like the little toolbox that we want to fix, and the message that we want to fix, and fixing wherever we've referred directly to worksheet cells in the rest of our code, because we want to instead use the functions that we just wrote. So we're going to just modify those quickly, and then we're going to look at the map and try and get our map to look a little bit prettier and not a solid square. Thank you very much, and please like the video, and I see you in the next session.